In this video, we're continuing with Chapter 7, talking about matrices. This is Section 7.6. We're going to talk about the inverse of a square matrix. So although we can figure out the inverse using the calculator very easily, you will be responsible for knowing how to calculate it by hand. It's really not that difficult, but as always, if you have questions, make sure that you ask. So let's start with the definition. So we're going to let A be a square matrix and let I be its identity matrix. So just so we're all on the same page here, an identity matrix, I'll give you an example here. This would be an example of a 3 by 3 identity matrix. So basically we have all ones and zeros, and notice the pattern of the ones and zeros. Okay, so this would be a 3 by 3 identity matrix. So A is a square matrix and let I be its identity matrix. If there exists a matrix A inverse such that A times A inverse would be equal to A inverse times A, which is equal to the identity matrix, then A inverse is the inverse of A. So you can see here something that we noticed was not always true. We noticed that matrix multiplication is not commutative, but in this case, if the matrices are inverses of each other, then it doesn't matter which way we multiply them, we'll end up with the inverse matrix. Alright, so let's take a look at example 1, and we want to show that B is the inverse of A. So if I multiply these together, I should end up with the identity matrix. So let's do A times B. And again, we're going to do this by hand. Make sure you know how to multiply matrices by hand, and I'll show you the steps for this. So we're going to take the first row and multiply it by the first column. So I have 2 times negative 1 plus negative 1 times negative 3. So that gives me first row, first column in our multiplication. Then I'm going to do first row times second column. So I have 2 times negative 1 plus negative 1 times negative 2. Alright, and now we'll go ahead and we'll do the same thing for the next row. So now I'm going to do this row times this column. So I have negative 3 times negative 1 plus 1 times negative 3. And then we'll multiply by the second column here. Negative 3 times negative 1 plus 1 times negative 2. Alright, let's figure out what we have here. So this is negative 2 plus 3. So negative 2 plus 3. This is negative 2 plus 2. This is going to be 3 minus 3. And then 3 minus 2, and then we'll go ahead and simplify, and we get 1, 0, 0, 1. So we ended up with an identity matrix. And since I got the identity matrix when I multiplied A times B, since A times B results in an identity matrix, A and B are inverses. Alright, and then again keep in mind that A times A inverse is going to be the same as A inverse times A. Alright, moving on. we want to find the inverse matrix of A if A is equal to the given matrix. All right, so again, we could do this on the calculator very easily, but I do want you to know how to do this by hand, and I will expect you to do it by hand on the assessment. So what we're going to do is we're going to take our A matrix, so 1, -2, -1, and 3, and we're going to multiply it by what we want to be its inverse. So I'm just going to put some variables in here. I've got A, B, C, and D, and we know when we do this multiplication that I want it to be the identity matrix. So whatever these values for A, B, C, and D are, I know that when I multiply this out, I end up with the identity matrix. So let's go ahead and use this to set up a system. So I'm going to multiply this first row by this first column. So I have 1 times A plus -2 times C, and we know that's going to have to equal 1. So the first row times the first column gives us first row, first column in our identity matrix. All right, and then let's do the second row times the first column. So I'm going to do second row times first column. So I have -1 times A, so that's -A, plus 3 times C. So this is second row, first column, second row, first column, so we know that has to be 0. So here's a system of 2 variables and 2 equations, and we'll solve that in a minute. And now let's go ahead and do some equations with B and D. So I'm going to do first row, second column. So I have 1 times B, which is B, at plus -2 times D. So that's first row, second column. First row, second column, we know that's going to have to equal 0. And we'll do second row, second column. That's going to give us this entry in the corner, so we know it's going to have to equal 1. So I have -1 times B, which is -B, plus 3 times D, and we know that has to equal 1. So let's go ahead and solve this. We could just do linear combination. These are going to cancel out. This is going to end up -2C plus C is C. So C is equal to 1. And then we can go back and substitute 1 in for C. So I'll have -A plus 3 is equal to 0. I'll subtract 3 from both sides and end up with A is equal to 3. And then let's solve this system. -2D plus 3D is going to be D. And 0 plus 1 is 1. These B's cancel out. So we can substitute D back into either equation. So if we plug it back into the first one, I'm going to have B minus 2 is equal to 0. I'll add 2 to both sides and get B is equal to 2. So then our final answer, our inverse matrix, is going to be A, which was 3, B, which was 2, C is 1, and D is 1. This is our final answer. All right, and then if you wanted to go ahead and check, you could just multiply these two matrices and make sure you got back to the identity matrix. All right, so let's go ahead and do this on our calculator just to see how we do that there. So basically, all you need to do is enter this into the matrix, and then on your home screen, you're going to go to matrix and then hit whichever matrix you put that 3 by 3 in, probably an A, and then you're going to hit the x to the -1 key, And if you want to pause it, and you can figure out what that is, so you can check when you come back. When you restart the video, the inverse will be up there, and you can check it. So go ahead and pause now and plug that in and see what you get. All right, so after plugging in A into your calculator and doing the inverse of it, you should get this matrix. And let's go ahead and do a quick check to see if we have it right. So let's do A times A inverse. So I'm going to have 1 times 4 plus 1 times 0 plus 1 times negative 3. So that's going to give us 1, so that's good. Let's do first row, second column. So 1 times negative 1 plus 1 times 0 plus 1 times 1. So that's going to give us 0, so that's good. First row, third column, 1 times negative 1 plus 1 times negative 1 plus 1 times 2. All right, moving on to the second row. So I have 3 times 4 is 12 plus 5 times 0 plus 4 times 1. Oh, I missed something. Times 4 times negative 3, so plus negative 12. There we go. All right, and then the next entry, 3 times negative 1 is negative 3. 5 times 0 is 0. 4 times 1 is 4. And then the last entry in this row, 3 times negative 1 is negative 3. 5 times negative 1 is minus 5. And then 4 times 2 is 8. All right, now our third row, so 0 times 4 is 0. Negative 1 times 0 is 0. And then 0 times negative 3 is also 0. Next, 0 times negative 1 plus negative 1 times 0 plus 0 times 1. And then last, we have 0 times negative 1 is 0. Negative 1 times negative 1 is 1. And 0 times 2 is 0. So let's go ahead and simplify. We've got 1, 0. Negative 1 plus negative 1 is negative 2 plus 2 is 0. And then 0, 1. That's negative 8 plus 8 is 0. And then a 0, 0, and a 1. So we in fact checked that this is the inverse of A, because when we multiplied them, we got the identity matrix. All right, so how do we solve a system using inverses? This is probably the way you solved systems of equations using matrices before. So, you know, we can use the reduced row echelon form every time. You don't necessarily need to use inverses, but we'll go ahead and look at that anyway. So we're going to let our A matrix be the augmented matrix for this. So we have 1, 1, 1. Notice I'm leaving out these constants here. Then I have 2, negative 1, 2, and negative 1, 3, and negative 2. So that's going to be our A matrix. So we're going to let the X matrix be X, Y, and Z. And then we're going to let the B matrix be our constants here. So I have 2, 1, and negative 2. All right, so I know if I multiply A times X, I'll end up with this system of equations here, and I know it has to be my B matrix here. So I know that A times X has to be B. So if I solve this for X, what we end up with is X is going to be A inverse times B. So I know it seems like it would be logical to divide both sides by A, but it's not really multiplication in the sense of what we think of as multiplication. It's matrix multiplication. So to undo this A, we have to do A inverse on this side, so then we do A inverse on this side. And this is the formula that you've probably used before by doing A inverse times B. So in this case, again, you're going to plug in your A matrix, which is a 3 by 3. You're going to plug in your B matrix, which is a 3 by 1. And then on your home screen, you're going to do A inverse, that's our A inverse, times our B matrix. And if you want to pause the video so you can figure out the answers before I put them up here, you can. So you should get -3, 1, and 4. So that's using inverses to solve a system. Again, for a calculator portion of an assessment, I don't really care which way you do it. I personally prefer the reduced row echelon form because you only have to enter one matrix, and you know, whichever you prefer. All right, so that's the end of this. If you want to go ahead and work on these 2 problems for the exit slip, and then you could check those when you get to class, feel free. Try and solve the first one by hand, because again, you'll be expected to do that on the assessment. Do it by hand without a calculator, and then for number 2, solve it either using reduced row echelon form or inverses, however you like. And we'll see you in the next video.